Morning, sir.
Good morning, sir.
Shall we start then? From where we stopped last time.
Yes, sir.
Hope everybody can see the screen, right? Yeah, can you all see the screen?
Yes, sir. We can see.
Okay, a couple of things. First one, I have put just now some notes of the previous designs in your LMS. Have you observed that? Have you seen that? I have put a couple of lectures on factorial, then nested design and split plot design. Have you seen that? Some notes, some supplementary notes. Have you seen?
No, sir.
So you can see, you can download and you can read. The other thing is in the afternoon today we will continue with the practicals, right? Hope today the internet connection would be better than yesterday. Right, we were talking about ANOVA or analysis of covariance, and yesterday we have introduced what is covariate. In which occasion the covariate is important because the covariate itself will be a result in the change of any ultimate results which can be considered in the experiment. Sometimes before the experiment we can consider the covariate, or in certain cases after starting the experiment we can consider the covariate. As an example, the field which is affected by the pest and diseases or pest, a particular pest. So that itself will create a problem in the measuring or the yield at the end. So that that pest population could be considered as one of the covariate in particular study. So we have learned that. Now we will go to an example and try to figure it out how really. First of all, what this ANOVA or analysis of covariance, and how it's really helpful to have high precise experiments, right? Right. So here we will take an example. We will take an example so that we could explain it better. Now we are going to do a small study. In this study, I'm going to explain the whole subject with this study. This study is based on animal science. People who are specializing in animal science can understand much better. Even other students also can understand better, right? I take an example from animal science. So calf weight gain. What do you mean by calf weight gain? Anyone? Why we are worried about calf weight gain? Anybody from animal science?
It is only attain weight calf at right stage only, then it can easily attain the keifer stage also, sir. Otherwise, it is too late to attain the puberty period.
Right, but actually, what are calves? What is calves?
Young one of the cattle.
Yeah. Do we separate male and female in calf? Calf mean, is it a common term for male and female, or is it specific? Huh?
Comment.
Common term, right? Calf is a common term. Usually, maybe not in countries like us. If you go to developed countries, they have once at the birth, you have two types of animals that you can obtain. One is the group of, let's say, in the cattle, right? In the cattle, you have two types of animals that you can say. This is milk cattle. Sorry, other way around. Huh? This cattle, once you get the community of female, that is for milk production. So milk cattle management. So you learn about milk cattle management. If you have male cattle, you cannot do anything with that. So what they do it for? Anyone? In foreign countries.
The culling, or they got the calf also, they got meat from calves.
So you might have studied from your animal science, right? It's called as production of beef cattle. In Sri Lanka, it's not very popular because, right, due to religious region and so on, there's nothing called beef management. But in foreign countries, yes, the cattle have been managed for beef production, right? That means for the meat production. So this is a story about the meat production. So in the meat production only, we are worried about the weight. In the milk production, we are not worried about the what is the ultimate product. If we are maintaining a cow or cattle for milk production, what is our ultimate objective? We want to increase the milk production, not the weight production. But to increase the weight production, the management, actually it's coupled with the production of beef or the meat. So here the story about the meat production, not the milk production. Huh? Weight gain for a calves, small calves, how we can increase the weight because in foreign countries, the meat production, the calves have been bred for meat production or managed for meat production, and they don't keep the calf for a long time. Within 2 years, they will slaughter. Within 2 years, they will slaughter, right? Not like in our places. In our places, even 5 years, 4 or 5 years, they will allow for, they use for other purposes, mainly for milk and everything, drafting, etc., etc. Then only they will go for meat production, right? So our system is different. So this is an example from a foreign country, right? So calf production based on this weight gain, that is mainly for meat production. So this example is meat production. So everybody understand meat production means ultimately the aim of the meat production is to have high weight of each animal. So that is the object, right? Now read the sentence one by one. An animal scientist wishes to examine the impact of pair of new dietary supplements on calf weight gain response. So normally in this particular farm, they are having a diet. Usually they are giving a particular diet. It is called as standard diet. It is called as standard diet. At the moment, they are giving a standard diet. Now, in the future, they are planning to introduce 2 new diets, because we want to evaluate whether these 2 new diets are better than the standard diets. So the first new diet, because we have two new diets they are introducing, pair of new diet. That means two new diets they are planning to implement. So what they are doing is, now we have a standard diet. In the future, they are planning to introduce a new diet, but standard diet with supplementary Q, that is one new diet. The second new diet is standard diet with supplementary R. So altogether in our experiment, 3 diets are there. The first diet is a standard diet. That is, now we are practicing. We are trying to introduce 2 diets. Before introducing, we will have to find out whether these 2 diets are performing better than the present diets. So these 2 diets, one is called as standard with supplementary Q. Standard diet with supplementary Q. This is the new diet 1. The other one is standard diet with supplementary R. So this is new diet 2. So we have 2 new diet. The standard diet, this is the old one that we have. So altogether we have 3 diets. Is it clear? We are going to experiment 3 diets. Standard diet, which we are practicing now. The second one is standard diet with some supplement. What do you mean by supplement? You learned already.
Provide the missing nutrients which are missing in the feed.
So yeah, we can provide some additional minerals or nutrients or protein or whatever it is, right? We are incorporating some lacking minerals or nutrients into the feed. That is called as supplement, right? So remember, these are 3 different diets that we are going to test. I have already introduced what is these 3. Right. Now, if you look at the animal point of view, we have 3 diets now that we want to test it. All new calves from large herd, from a big herd, large new herd are available for the use of this study units. The researcher, actually it's a lady researcher, she selects 30 calves. We select 30 calves for the study, right? We want to, so how many calves randomly we can allocate for each treatment? If I select
10 calves.
10 calves for standard diet 10, standard diet with supplement Q10 and with R10, for example, right? So calves are randomized. Now we don't give any priority to any calves for any treatment. We randomize, and these 3 diets at random, we give it to the calves so that the initial weight are recorded. So now, because very difficult to get the same weight of all 30 calves. All 30 calves will not be having the same weight. So that for our information, I have recorded initial weight of all these 30 calves, because all are recorded, right? So I am taking initial weight of all these 30 calves. Then calves are pulled into the diets at the end of, right? So as you all said, 10 calves each for each diet has been placed. Immediately after giving the diet, we cannot measure the weight gain, isn't it? After giving some meal, we'll have to wait for some times, right? It's called as grasping period, right? Some period you'll have to allow because it will work gradually for some time. So the final reading has been taken 4 weeks after the treatment given to the animals. We are taking the final weight of the animals. Right? Is it clear to everyone? You will have to understand first the question. So we select 10 calves each for each treatment, and we record their, because these 10 calves randomly we select, and we record their initial weight, then we give the treatment, and at 4 weeks after that, we measure the weight of all these calves. Right, now, without considering anything, can you tell me what kind of design is that? Without considering ANOVA and so on, what is the simplest design that we can apply?
CRD.
CRD, yes, CRD. CRD is the simplest design because we have 10 replicates for each treatment. Randomly we select because all 30 has been kept in random. There's no any priority. So it is a CRD, simple CRD. If we are not considering anything else, only the final weight, right? The simple analysis of variance associated with multiple comparison procedure, you will learn about the comparison later on. Multiple comparison or the mean comparison indicate no significant difference in the weight gain between two supplementary diets. So what the results is, actually we are doing a CRD. After doing CRD, we have some, maybe today or tomorrow we will talk about mean separation. We want to compare this standard diet, standard with Q, standard with R. So these are the three diets, isn't it? When we compare, the result says there's no difference between these two. That is what it says, the first sentence. No significant difference in weight gain between the two supplementary diets. ഇത് രണ്ടുക്കും ഇടയിലെ വ്യത്യാസം ഇല്ലാണ്ട് നിങ്ങൾക്ക് റിസൾട്ട്സ് വരും. අපිට results එන්නේ මේ දෙක අතර වෙනසක් නැහැ කියලා තමයි අපි results එක පෙනෙන්නේ. Right? But look at the second sentence. But there is a difference between the supplementary diet and the standard diet. If you compare this and this together, then there's a difference. That is the results that we are getting. So we, in this normal CRD analysis, we obtain the results saying that there's no difference between these supplementary diets, but there's a difference between the standard diet and the supplementary diet. That is the results. Right? Now, can we satisfy with that results? Because already there's a treatment effect, because standard diets are doing better than the, standard diets with supplement are doing better than the standard diet. So that can we satisfy ourselves? Can we stop with that? If you want, you can stop with that. But if you want to do a better study, because this study is not harmful, but if you want to do a much more precise study on this results, how we can approach, right? Is it clear to everyone? If you don't understand, you ask me this. Right, now I'm taking the data of these diets, this ANOVA results. So you look at the scale. So this is the scale. Average value is there. Of this is the standard diet, right? Average value of supplementary diet, standard plus supplementary diet is, that is the scale. The third one, the scale again, more or less same scale, supplementary R. So do we have a difference between these two, supplement Q and supplement R? මේ දෙක අතර වෙනසක් තියෙනවා. ඉතින් රණ්ඩ ගුණවල ව්‍යත්‍යාසම් ඉරකෝ mean ල. I have drawn the mean value. No, because it is the line is more or less. How about the difference between the standard diet and the supplement diets? Yes, there's a difference. So this difference indicate that there's a difference between standard diet and the rest of the supplementary diet. So this is my average weight gain. It's given in the response in grams per day or whatever it is. Don't worry about this grams per day or kilograms per day or whatever it is. Some indication. So here we come up with this is the normal analysis procedure. Are we satisfied with this, or do we want to go for other things? Right, now we have yes, this is the indication. In a simple ANOVA of one-way classification, we would suggest no difference between supplementary Q and supplementary R. But there's a difference between the supplements and the standard diet. This is our conclusion by doing the normal analysis, not the ANOVA. Now we are going to look at the ANOVA, why the ANOVA is important. Now what I do is, I'm going to plot the initial weight. Can you remember initial weight of 30 calves? 10 calves allocated for standard diet, 10 calves as allocated for supplement Q, and another 10 for supplement R. Do you think all these 30 calves are having same weight, initial weight?
No.
No. So I'm putting them on a scale again, just to show you. If you put it on a scale, you see here, they are having in different scale, initial weight, average initial weight. I'm just taking average initial weight. Then only we can explain this easily. So you see, this is the average initial weight for standard diet. So this is the average initial weight for standard diet. So for the supplement Q diet, this is the average. For a supplement R, this is the average. Now you see, are we taken the animals with the same average or different average? For the three treatments. Different average. So you see, this is the problem. When you give a treatment, all aspects should be same. Right? Yesterday, I was talking about Panadol, for example. One Panadol may be good enough to one person to cure the headache. For the second person, maybe 1.5 Panadol would be better than one Panadol. For the third person, 2 Panadol is better. But they are in the same age. They are in the same age. I took 2 examples, I think Tanis Kumar and Rania as an example. So you see, this is the problem. Why? Their metabolisms are different. These metabolisms are depend on various things, but depend on the weight as well. Right? Depend on the weight as well. Okay. So similarly, here also, in these 3 cases, actually, if you look at the initial weight, average initial weight of the cows for the 3 treatments that we have taken are not really in the same weight. They are showing a different weight. Right? So this weight itself could have created some variability. That is the problem. Right? If they are in the same line, no problem. We don't have any problem. But here, they are not in the. So this is what we are going to discuss in the analysis of covariance. How we can adjust them in the analysis of variance. What we are going to do is, we are going to adjust, for example, their average values according to, let's say, one scale. I'm not going to say which scale. We are going to adjust this to one particular line, whatever the line. I'm not saying it is to the standard line, whatever the line. So we are going to bring them into one line and study about how their relationship is, right? So that is the overall aspect of this. Right, weight gain to initial weight on a standard diet. In a standard diet, what is normally happening with the age? What do you think? Sorry. With the age, we are talking about standard diet. Now we are not going to talk about, for the explanation, weight gain to initial weight, standard diet. So age versus weight, how we can define this? So this is how normally the situation is, all right? If you fit a line, ad libitum feeding, if you have ad libitum feeding, we can have some kind of relationship like this. Age with the age versus weight in kilogram. Age maybe in years or months. If animals come into the study at different stages, different ages, for example. So what I'm saying is different ages mean even the ages may be defined months, right? They have different initial weights. If they are coming in different age, usually they have different weights. We can assume that. And are at different points on the growth curve. So they will be at the different points on the growth curve. Expected weight gains will be different depending on the age of at the entry. For example, look at it, the animal coming with the age, a particular age, is coming with the age there, and its initial weight is Wi. The second one, another animal coming, right, with the age, difference in months, but he's coming in different age, so that higher age than the previous, so that it is having WF. The weight is now WF. This is the initial weight, don't forget. Now, what is the weight gain for this particular difference? It's actually this weight gain can be said Wi minus WF, right? So here, this is the initial weight. This is final. If an animal come to the experiment at this stage, its initial weight is this. After 4 weeks, this is the story. As an example, after 4 weeks, this is the story. This is my final weight, right? So this is my weight gain. This is my weight gain for the one animal. Look at another animal. This is this animal coming in the initial weight as that, because at the age is different. After 4 weeks, the final weight is that. So weight gain is that. So now you see, here we set weight gain for the first animal. This is initial weight. I mean, this is the age at the initial. This is the age at the final. Now, the weight gain for the second animal, this is the initial age, and this is the final age. Final age means at the time of the experiment over. So the weight gain, you see, this is the weight gain. Can we compare weight gain of second animal and weight gain of first animal? Will it logical? It is not logical. Why? For example, if we have a graph weight with the age like this, then it is logical. Because here, one animal coming as an initial, their final weight is this, right? Initial weight. So this is the weight gain, no problem. If you take the second one, this animal comes in this age, right? And the final weight is somewhere there. If you draw it, so the weight gain here. So let's say this is X, this is Y. X is equal, more or less equal to Y. Here, we weight gain of first animal not equal to weight gain of second animal. Do you agree with that? Why? Because the relationship is not linear. It is this kind of curved relationship. Therefore, this is a problem, right? This is the situation. So you can read the weights and at different points on the growth curve. Expected weight gains will be different depending on the age of the entry of these animals to the study, right? Depending on the age of the entry of this animal to the study, the weight gain will be different, right? Right. Let's talk about this weight gain, which I have already just now mentioned. If you have a straight line, right? Initial weight of first animal, all right? So here we are talking about regression. Can you remember, yesterday I mentioned ANOVA is the combination of ANOVA and the regression. So here we are getting a regression part also. So just to explain this regression part, the initial weight of the regression of the initial weight to weight gain. We are comparing the initial weight. So this is the initial weight and the weight gain. The relationship between initial weight of the first animal and the second animal, they are linear. The initial weight of the relationship between initial weight and the weight gain for each animal, it is on a linear. If we discard the age of the animal, but instead, if we focus the initial weight, for example, we see that there is a linear relationship between initial weight and the weight gain expected, right? So this is how it can be explained, so that we could say we can introduce the covariate initial weight. Why initial weight is important? Because in this case, age cannot be considered as initial consideration in this situation, because we are ultimately looking at the weight gain. So this weight gain has a linear relationship with the initial weight, so that we are going to take the initial weight as the covariate, right? Initial weight in the early examples can be considered as a covariate. A covariate is a disturbing variable. It's called as confounding. When you have variability overlaps, it's called as confounding, right? That is, it is known to have an effect on the response. Usually the covariate can be measured, but often we may not be able to control its effect through blocking. So this is a problem. So we cannot control the covariate through blocking. Non-gradient system of variation. If you have a kind of a gradient, then we can control it using blocking. But here we cannot do the blocking. We know that there's a variation in weight, but the weight is not coming in a very nice systematic way. If it is coming in systematic way, yes, but it's not coming in a systematic way. In the example, had the animal scientists known that the calves were very variable in initial weight or age, right? So that is the first thing. Yes, it is very variable. We can create, we can do it in another way also. We can create a block of 3 or equal weight of the animal and randomized treatment to the cows. So that is, we can do it in another way also. What is that way? For example, we have 30 calves. We can put the calves in ascending order, right? Let's say we start with some kilogram, 30 kilogram, 32, 35. This is the lowest value. Huh? Likewise, 37, 40. Oh, these are very high values. I will start with 30, 30.5, 31.2, 32.3, 32.8, 33.1, 33.3, 33.6. Likewise, you put all the 30 cows in ascending order. This is one way of doing without going for analysis of variance. So how many treatments are there? We have 3 treatments, right? So we block them. This is block 1. We block the second one, block 2. We block, this is block 3. So we can have blocks. So how many blocks we can have?
10.
10 blocks we can have. Now I have 3 treatments: standard with Q supplement, standard with R supplement. How to treat this? Now we can select randomly. So I may say, if I take randomly, this is Q, this is R, this is S. So next time when you do randomization, here this is S, this is R, this is Q, for example. So randomization, right? We can randomize it, all treatment within the block. So this is one way of doing. This is a simple RCB. This is also better. But here, ANOCOVA is better than the RCB. Why? For example, look at it here. One cow is 30 kilogram, another one is 31, another one is 32, another one is 33, another one is 34, another one is 35, 36. Now you see, if you block it here, this is better. Here we can do the RCBD very nicely. Why? Here you see the differences, weight differences. Not really, because the difference between here is 0.5. Difference between here is 0.7. Difference between here is 1.1. You see, these differences are not uniform. Here, what about differences? Let's say this difference is 1, this difference is 1, this difference is 1. This difference is 1, this difference is 1, this difference is 1. So this is, in this case, applying RCBD is okay, no problem. Right? Because this is very unique value of differences. Can we get animals like this? Can we get animals like this for our experiment? We need 30. No, we cannot get animals like this. So we get animals like this in this weight order. So we look for a better analysis than RCBD. So we can apply RCBD also, but we look for better analysis than RCBD. That is why we are going for analysis of covariance. So here in this explanation, one can say that they can go for RCBD, no problem. We can create into 3 animals per block or 6 animals per block, right? So it is called as replicated RCBD. We didn't learn about. If it is 6, it is called as replicated RCBD. So we didn't learn that, right? So you see 3. If you create 3 animals for each block, then we can apply normal RCBD can be applied in a usual way. This would have entail some cost in terms of time and other aspects, but the precision also less compared to the analysis of covariance. So it was much easier to simply record the initial weight of the animal, then we do the analysis of covariance. Right? In many cases, due to the continuous nature of the covariance, blocking is just not feasible. So blocking is not feasible, as I said. The variability, which I said already, the variability is not uniform. It is it's random. Right, now we come to that. Expectation of my null hypothesis. Expectation of null hypothesis. Under the expectation of null hypothesis, what is my null hypothesis normally? No, I will put it as no treatment effect. That is my null hypothesis, isn't it? No treatment effect. So you see, it is already there, no treatment effect. That is under the null hypothesis, right? If all the animal had come in the initial stage, all the animals had come in with the same initial weight, normally that is not happening. If they would have come with the same initial weight, all 3 treatments would produce the same weight gain. So that is what we say, there's no treatment effect. Am I right? If all the animals, all 30 animals comes with the same weight, this is just theoretical thinking, right? If all the 30 animals coming with the same weight, if all 3 treatments are producing the same results, we can come to a conclusion that there is no difference between the treatment effect. All feeds are giving the same weight gain. Am I right? Yes, that is what we are saying. So the average weight of the animals for all treatment is same. So expected weight gain for all treatments are same, right? So that is a theoretical aspect. But if it comes, then we could say there is no treatment effect. But on the other hand, right, if the animals come in, alternative, if you look at the alternative hypothesis, what is the alternative hypothesis? At least one treatment mean is different from the rest. Am I right? At least one treatment mean is different from the rest. That is how we interpret. So under the alternative hypothesis, again the same scenario, theoretically, all the animals, all 30 animals are coming with the same average, because we say average, almost closer to the average weight of the animals, right? They are coming to the initial, but there's a difference. This is a standard diet. This is supplement with R. This is supplement with Q. So there's a difference, actually. There's a difference, so that we could say significant difference between treatment effect that we can come up with, right? So different treatments produce different weight gains for animals for the same initial weight. So then we can accept our alternative hypothesis and we say there's a treatment effect. That we can say. These are some theoretical background. So if the initial weight is same for all the animals, these two are the 2 examples. So earlier one is we say we accept our null hypothesis, that means no treatment effect. There's a treatment effect. Treatments are different, or the weight gains are different. Now in the actual scenario, the real scenario, this is the story. Why? All the animals are not coming with the same weight. All the animals are coming with a different weight or different initial weight, right? Different initial weight. So under that, if I come with the no treatment effect, null hypothesis, no treatment effect, suppose if the average initial weight in the treatment groups differ, the observed weight gain will be different even if the treatment have no effect. Do you agree with that? Because they are having initial different weights, different initial weights. If they have different initial weight, definitely their weight gain should be different. Even there is no treatment effect. Right? So for example, one cow is 30 kilograms. Right? Another cow is 35 kilograms as an example. So here I am applying treatment R. This is treatment Q. This is treatment standard. This is with 37 kilograms. So here the increase is, let's say, 32. Do you think this increase will be 37? This increase will be 39? No. This increase will not be like this. So this is, if the increase is like this, then this is called as no treatment effect. Because everything is increased by 2 kilograms. Do you understand? So this is the scenario that I am explaining. So 30 kilogram one increased to 32. So increase is 2. 35 kilogram is increased to 37. Increase is 2. 37 is increased to 39. So these are the three diets, R, Q, and the standard one. So here no treatment effect. But you see here, even though there is no treatment effect, there is a difference here. Due to what? Why that difference is? Why that difference is?
Because initial weights were.
Yes, because of its initial weight. Even though there is no treatment effect, because of the initial weight. Normally we don't get this, but this is the problem. This is the problem in experiments. So here we could say, even though there's no difference in the treatment effect, but still the final weight might vary. That weight is actually, this is initial, because of the initial weight. Right? Because initial weight, you see, this is the supplement Q. This is the standard diet. C means standard diet. And R means it is the diet with the supplement R. So they are starting at different points as the initial weight. So this is one of the problems in our study. Right. Now, this is a little bit more advanced one. If you look at, if I want to say under the condition of when the initial weights are different, these are the initial weights are different. Right? They are having a different initial weight. Under that, if you want to accept that there's a treatment effect, then we'll have to consider, this is what we are going to look at using analysis of covariance. Right? You see, we want to develop. So this is the weight gain by the Q, average weight gain by the Q, average gain by the standard diet, average weight by the supplement R. So now how all these are in three different levels. All three are in different levels, but still we could say there's a treatment effect. There's a treatment effect, but we cannot visualize very nicely how it is. Right? Suppose now that different supplements actually do increase in the weight gain. In the earlier case, no weight gain increase. Now, really, the supplements increasing the weight gain. This translates to the animal in different treatment groups following different, but we come up with regression lines for different initial weights. So what difference in weight gain is due to the initial weight and what is due to the treatment? So that we'll have to extract it. For example, here we said there's a weight gain of Q, R, and S. Suppose if you take the weight gain of QR, so weight gain of Q can be due to initial weight, because can you remember, because the weight gain earlier slide we said that it is maybe due to initial weight, and also due to the treatment of Q. Weight gain of Q can be separated. So that is what we say, what difference weight gain is due to initial weight, what difference is due to the treatment. So this is true for all cases, not only W weight gain of Q, it is true for weight gain of R, it is true for weight gain of standard diet. Right. So this is because you can follow, I will put this also on the LMS. So you see here, this is about the standard diet. This is about the supplementary R. This is about the Q, just for the explanation. Now, what we are doing is this two slide. First slide is, look at, we are doing some adjustment. We are doing some adjustment. In earlier case, you see, we want to adjust this. We want to adjust, maybe we can adjust, sorry. We see here, this is one position, this is another position, this is another position, so that we can adjust. We want to bring this into alignment, maybe right side or left side, whatever side. All three initial weight, group of initial weight could be bring into one line. For example, I want to bring this into this direction, this into this direction as an example. Then how it's look like, right? How it's look like. So that is the basis of this ANOVA. So now you see, now we are comparing, observing group means in a simple ANOVA that we did it early. CRD, can you remember? If you could have done in CRD, this is my results. We didn't consider the initial, sorry. We didn't consider my initial weight here. We don't care about it. So we get the results. This is the average value of average yield or average weight gain of the Q diet. This is the average weight gain of R diet or supplement R diet. And this is the average weight of standard diet. You see? So this is called as unadjusted treatment mean. So if you could have done simple CRD, the treatment means are not adjusted according to the initial weight. Because we already said the initial weight is a main factor which has to be considered. So here you can see simple one-way classification of ANOVA will lead to a wrong answer without accounting the initial weight, because there are different initial weight. No. So how we can adjust this? How we can correct this? So this is uncorrected means. Now we can correct it, as I said earlier, right? Because one is sorry. The diet Q had the line somewhere there. Diet R, supplement R had the line there. So what we have done is we have shifted these two lines towards one direction, right? Towards the middle one. which is we are adjusting according to the standard diet. So that is what we have done. So expected weight gains is computed for the treatment for the average initial weight, and the comparisons are then made. So you see here, we are adjusting the values. Here, this value is adjusted according to here. This value is adjusted according to there. And this is already there in this. Here, this is in this direction. This is on that direction. So we we adjust the value. Now everything is adjusted according to the initial. So now it is called as adjusted treatment mean. So I'm just explaining the concept. Don't worry about the calculations now. So the concept is we are adjusting the treatment mean. That is what we are adjusting according to what? In this case, initial weight. Right? We are adjusting according to the initial weight. Right. Then only we can identify whether there is a treatment effect or not. Now we have adjusted the means. Look at it. Can you say this is the adjusted mean of standard diet? This is the adjusted mean of, I will say, adjusted mean of standard diet, adjusted mean of, we call it as not predicted value, right? Just predicted value of standard diet, predicted value of supplementary R, predicted value of supplementary Q. Now tell me, do they have differences? Look at here, there are differences. So according to this, what is the better diet for the animal, which increasing the weight? Which is the better diet if you adjust for initial weight? Arosha?
I think ours don't know.
Huh? You think?
R.
Balanda R.
Q.
Huh? Q. Look at it. Because Q has been adjusted, because this line belongs to Q. So this has been adjusted there. R line belongs to this. It has been adjusted there. So this is belongs to R. This is belongs to Q. So which one is having higher diet? Q is having higher diet, higher gain than R, than standard. When we did ANOVA, what we said, Q and R is having more or less same value than the standard diet. Standard diet is lower, Q and R is having behavioring similar. But here we prove that Q is much better than R, right? So that there's a difference. So you see, this is the advantage of ANOVA, right? ANOVA. Right. ANOVA objectives. The objective of analysis of covariance is to compare the treatment means after adjusting for difference among the treatments due to differences in the covariate levels for the treatment groups. So that is the objective of ANOVA. The analysis proceeds by combining a regression model with the analysis of variance model. So this is ANOVA. If somebody asks, it is the combination of regression and the ANOVA. Any questions? Right. So this is how we write down the model. So carefully you look at the model. This is how we write down the model. Right. This is how we write down the model. Right. Look at the model. So Yij This is for CRD, yeah? In the ANOVA also, because we said combination of analysis of variance and the regression. So we can combine in different forms, all right? So this is observed value of ith treatment in jth replicate. Ith treatment in jth replicate, no problem. That is Yij. So this is how we say I is from 1 to T, J is from 1 to R. R is replicate. In addition to that, here we have beta. That is the slope coefficient. Can you remember? We are introducing a regression. If you introduce a regression, definitely there will be a slope line. So here, this is the grand mean, the treatment effect. Now this is the adjusted value actually, right? So we include that also into the model. We'll come to the ANOVA later on. This is written as beta into Xij, that is the observed value of initial weight. X is the covariate here. Write down X is the covariate. Ij mean it is the first value. For example, here we have treatment, yield mean whatever yield, meat yield or whatever it is, covariate. So here, this is Y11, this is X11, Y12, X12, Y13, X13. Similarly here, treatment, it is 1, 1, 1, first treatment. Right? So this is first treatment, first replicate. If you want, you can think about it, replicate, this first replicate, second replicate, third replicate, and so on. So everybody knows what is the notation for X. X mean it is a covariate value. Initial weight in our example, minus the X bar. It is the average of adjustment into beta. This we'll have to calculate using computer or by manual. Then the error curve. Right? So adjusted treatment means we don't want to calculate by hand, but computer will calculate. So this is the first treatment mean. This is, for example, first treatment mean minus beta, mean of the first treatment initial weight minus the overall weight of the covariate. X mean it is a covariate. So here 1 dot, right? So this we can say it for the first treatment. Likewise for the second treatment, the adjustment, the second treatment, third treatment, and so on. So this is the model. You don't need to write this thing because already, I will put this into the LMS, but other things what I have discussed, you'll have to remember. Yes, these are some of the information. You don't need to write, just have a look because you may write in a wrong way. So have a look. This is not the ANOVA. This is some calculation before we do, before we construct the ANOVA. ANOVA is a little bit complicated. So you see ANOVA table, this is the preliminary information for the ANOVA table for CR. Source, for example, treatment, error, total. So this is how we calculate the treatment for X, treatment for Y, and treatment for XY. You know what is X, what is Y? Anyone? What is X and what is Y?
Y is body weight.
How do you call that in general? What is the name? Huh?
Dependent variable.
Up to now, I was referring because when you do regression, yes, we can say. But here it's a combination of regression and ANOVA. How do you call this specific X? It has a special name.
Covariate.
Covariate. Don't forget that. It is covariate. What is Y then? Simple. It is normal as the other one. It is the response that you are measuring. For example, so let's say here, treatment, replicate. In CRD, yield, right? First treatment, first replicate, you have 25. First treatment, second replicate, you have 28. First treatment, third replicate, you have 29. Second treatment, first replicate. Second treatment, second replicate. Second treatment, third replicate. Likewise, you have the values. Now we are taking a value. This is called as covariate. In our example, what is our covariate in this animal experiment?
Initial weight.
Initial weight. This may be 23.5 kilogram initial weight. This may be 25.8 kilogram as the initial weight. So likewise, we have the additional information. This is called as covariate. So here, the response, this is response. Or this is also called as Y. Can you remember in the model, we write it as Yij, blah, 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 blah. So what is this Yij? This is the observed value, this one. Nothing else. When you say X and Y, what is that? Yesterday I mentioned about that. It's a cross multiplication of this value and this value. So that is coming as XY. What did I say in that? Covariate, the variance of X, variance of Y. If you combine and calculate the variance, it is called as covariance. Yesterday I mentioned about this. So that is why here covariance, we are talking about covariance. Right. We will go back to the formulas. So don't write these formulas. I will put this in LMS. Right. What is on the slide, you don't need to write. Treatment, you can calculate this. These are some of the preliminary information that you need to calculate. Any question that this is X, you understand, covariant. This is Y, this is the response. So this is XY. Some of the components that we will have to calculate. TXX, this is how we calculate. TYY, this is how we calculate. TXY, this is how we calculate. Total sums of squares, this is how we calculate for each of these components. If you have any doubt, you ask me. The error is always total minus, right? Error is given as EXX, EYY, EXY. So the total minus treatment, which is given as error, always. So that is why I am giving as subtraction. For example, EXX is equal SXX, SXX minus TXX, as an example. Anybody have any questions on this notations? Dhanush Kumar, any questions on notations?
No, no,
Okay, then these are notation. This is not ANOVA, right? Now I am going to put up ANOVA for CRD. Sorry, ANOVA for CRD. This is the real ANOVA for CRD. Now you see, in a normal CRD, can you remember, we have treatment, error, and total. Here we have additional information, regression. I said it is a combination of regression and ANOVA, so that it's there. Now don't ask what is TYY. It is from the previous calculations. TYY, SXY, EXY, and so on. Right? Then the regression, because treatment degrees of freedom, regression, error degrees of freedom, then the total degrees of freedom. Then we have sums of square for each of these regression, and error sums of square we can calculate that, otherwise total minus the rest. That is also possible, right? Sums of square of y. So mean square, these are called as adjusted. Can you remember? If you don't have regression, it is called as sums of square. But we can go for sums of square adjusted here in this ANOVA. So these are mean squares for respective treatment, regression, and error. We calculate for regression as well. Now we can test this. If you test this, this is the testing for treatment effect. We can test that for treatment effect. What is the test for this one? Why we want to test this one? Anybody? We can test that one also. You make a note of it, huh? We can test for that. What is that? For what purpose that we are doing test of that? Anyone?